Assalamualaikum and hi. So our topic for assignment is application of function and graph in real life. So this is our group members. First, Adik Mushrif bin Abdul Ali. Second, Alfian bin Faizul Zurami. Third, Muhammad Fahmi bin Muhammad. And last is Muhammad Irfan bin Muhammad Shukri.
In this slide, we will presenting the introduction, problem statement, and so, what is function and graph? Function and graph is like a machine where you put something and it gives you a specific result, which is input and output. The graph of a function is a picture that shows how the input and output values are related. It's usually drawn on a coordinate plane with the input x on the horizontal axis and why we use function and graph. A function explains how one thing depends on another, while graphs give a picture of relationship, making it easier to see patterns and trends. For example, in business, they help predict profits and track sales. In science, they show how objects move or how disease spread. And in daily life, they help with budgeting or tracking progress like weight loss.
These are the problem statement. The first one, finding the maximum height of a fountain's water spray. The second one, finding where a ball returns to the ground. The third one, comparing the heights of two fountains. The fourth one, finance and budgeting. Problem 1. The height y in meters of water spray by a fountain after it has traveled x meters horizontally is given by the equation y equals to negative 0.5x squared plus 2x. For the solution, we take the equation y equals to negative 0.5x squared plus 2x and we identify which one is A and B. As you can see, negative 0.5 is A, meanwhile 2 is B. We have the second equation which is x equals to negative B over 2A. Then we substitute value of A and B into the equation. And then we will get x equals to negative 2 divided by 2 times negative 0.5. And then we will get x equals to negative 2 divided by negative 1 equals to 2. Then we substitute value of x into the equation to find y. Then we will get y equals to negative 0.5 times 2 square plus 2 times 2 equals to negative 0.5 times 4 plus 4 equals to 2. Thus, the maximum height of water fountain is 2 meters.
Next, for problem 2, the given equation is y equals to negative x squared plus 4x. Determine how far the ball travels horizontally before it hits the ground. So, for the solution, we replace the value of y equals to 0 because it states that when it hits the ground. So, we determine the value of x. So, we got that balls travels 4 meters horizontally before it hits the ground.
For problem 3, the statement that given is two fountains spray water upward and the height of their water spray after traveling x meters horizontally are modeled by the equation. So for the first equation is y1 equals to negative 0.25x squared plus 3x, and then the second equation is y2 equals to negative 0.5x squared plus 4x. So for the question is determine the horizontal distance x at which both fountains reach the same height. For solution of problem 3, we equals the equation of y1 and y2. So for the equation is negative 0.25x squared plus 3x equals to negative 0.5x squared plus 4x. And then we solve and get 0.25x squared minus x equals to 0. And then we factorize and we got the first bracket is x and the second bracket is x minus 4. And then don't forget to write equals to 0 after the bracket. And then we get the answer is x equals to 0. And then we get the second answer is x equals to 4. So the two fountains reach the same height at a horizontal distance of 4 meters.
Okay, moving on to the next problem, which is problem 4. A person is saving money in an account that earns an annual interest rate of 4%. They initially deposit 2,000 ringgit into the account. The amount of money in the account after T years can be modeled by a function a the bracket of T equal to 2000 bracket 1 plus 0.04 power of T, where a the bracket of T represents the amount of money in the account after T years. So the question is, determine how much money will be in the account after 5 years. The second question is, use the function and its graph to visualize how the savings grow over time. The last question is, estimate how long it will take for the account balance to reach 3,000 ringgit. Okay, for solution 1, problem 4, we can take back the question that have been given in the question, which is a bracket of T equal to 2000 bracket 1 plus 0.04 the power of T. Okay, which is T is equal to 5, and we can substitute back the T in the equation, and we have a bracket 5 equal to 2000 bracket 1 plus 0.04 power of 5. Okay, we can insert it at our calculator and get the answer. And after 5 years, the account balance is approximately RM 2,433 and 33 cents. Okay, for the solution 2 of problem 4, as we can see, these are the graph that we obtain with the equation given in that question. So to obtain this, we must substitute the t value with 0, 1, 2, 3, 4, and 5. And if we calculate it in our calculator, we should find the same value as this picture shows. Okay, for the last solution of problem 4, we can make the equation based on the question given, which is a the bracket of t equal to 3000, since we must estimate how the balance will take until 3000 ringgit. So 3000 equal to 2000 bracket 1.04 power of t. Okay, since we can simplify it, we can divide by 2000. So we will get 1.5 equal to 1.04 power of t. Okay, to calculate the value of t, we must add ln on both sides. After we add ln, we can bring the t to the in front and calculate the value of the ln on both sides. After that, we can bring the 0.0392 to the left, which it will divide the 0.4055, and in the end we will get the t equal to 10.34. So the answer is the time that will take for the account balance to reach 3000 is approximately 10 years.
For the conclusion, functions and graphs are important tools that help us understand and solve real-life problems. In many situations, we can use mathematical functions to model things like profits, costs, and other everyday scenarios. For example, in business, functions like the one we use in the revenue problem help companies figure out the best number of products to sell to make the most money. By finding the highest point of a graph, companies can determine the optimal amount to produce or sell to maximize their profits. The shape of the graph tells us whether something is increasing or decreasing. In life, we use this tool to make better decisions, whether it's planning how much to produce, how to design a system, or even how to manage our finances. Understanding how to use and interpret functions and their graph help us make smarter choices, avoid waste, and reach goal more effectively.
So I think that's all for our group. Thank you.